Rubik's Cube Methods Episode 5, LEOR. Today, we are going to be taking a look at the LEOR method. Now, you might not have heard of the LEOR method before, and that's because it's a fairly new but severely underrated method. This method really shines in the one-handed department because this method was specifically designed for one-handed. I do think for a lot of cubers out there, this could be the best method for one-handed solving. The reasons being are that this method is extremely ergonomic. It mainly uses RU and RY moves, which is very good for one-handed, and these are moves that are very easy to perform, unlike M-slice moves in RU. LEOR also requires no rotations, and from the very little I know about one-handed solving, rotating is a big deal, and oftentimes one-handed solvers will have to come up with their own methods to smoothly rotate and turn without wasting so much time. So doing a one-handed solve without rotations is not only a huge plus, but a major relief. For two-handed solving, LEOR isn't bad. Like, it's not the worst method to use, and it's actually quite decent, but I wouldn't recommend it. Overview of the steps. So just like in CFOP, LEOR is actually an acronym of its steps, and I will just tell you what each letter stands for and what the step would look like. Step 1. The L stands for left block. Left block is just like first block in RU. Step 2. The EO stands for EO stripe. Yes, LEOR is an edge orienting method, and in most edge orienting methods, there will be the EO step, and immediately after that, you would solve a few pieces. In the ZZ method, there is EO line and EO cross. So in EO line, you solve your DF and DB edges to form a line. In EO cross, you solve a cross on the bottom. In the SSC method, there is EO edge, and basically, that's EO line rotated 90 degrees. In the ECP method, there is EO face, where you just solve a face on the bottom, ignoring the permutation of the pieces. In LEOR, EO stripe is just solving your DF and DB edges to form a stripe. Step 3. The R stands for right block. Right block is just second block in RU. After that, you can solve your last layer with any method you want. And I'm going to be using OCLO plus PLL. Now let's get into the tutorial. If you're already familiar with RU block building, you can skip to this timestamp on the screen. But if you do not know much about block building, stay here and stay tuned because I will be showing you free methods of block building as well as some techniques, tips, and tricks. Method number 1, CFOP style. CFOP style block building is where you first solve the edge that belongs in the down left position. This is called the DL edge. So this would be the DL edge. Then you solve the two pairs adjacent of the DL edge. So here's the first pair, and here's the second pair. Method number 2, line block building. Line block building is where you first solve the two middle layer edges of the block. So this one and this one. And then you solve the first layer block. Method number 3, square then pair. Square then pair block building is where you first solve a 1x2x2 block. So something like this. And then you would extend the block by solving the second pair, which is right here. Technique. Oftentimes you can build your block by pairing up the first layer edge with a first layer corner and treating it like an F2L pair. This technique works especially well if you already have these two pieces solved together in a scramble, or the middle layer edge that solves with the pair is oriented. Tip: if you ever run into a particularly bad F2L case, like this one right here, where we have the white corner facing us, and we have the edge on top, and these two colors do not match, you can always influence the edge or the corner of the pair to make the case better using the free space you have not having a cross on the bottom. So for this case, I can just flip this edge like this, and now I have a better case. Or in this case, I can just bring down the corner and now I have this easy pair. Trick: If you ever find that you can't insert a pair without rotating, remember that this isn't CFOP, this is root-style block building. If the pair is in front, you can just solve it with either F prime or L wide U prime. If the pair is in the back, you can do with B or L wide U. What is EO, edge orientation? Edge orientation is a step in solving the cube that doesn't solve any pieces, but it makes a huge impact on the steps that succeeded. On the cube, there are two types of edges. The first edge type is a good edge. A good edge can be solved with the following moves: R, L, U, D. This white-green edge is a good edge because we can solve it with U and R moves. Good edges are also known as oriented edges. The second edge type is a bad edge. A bad edge can be solved with the use of F or B moves. This yellow-green edge is bad because we have to solve it using F moves. Bad edges are also known as misoriented edges. The goal of edge orientation is to orient all the bad edges so we can make solving the cube easier, prohibiting weird FU-BU algorithms and rotations, and permitting fast turn speeds and fluidity. How to detect good and bad edges. First, we must learn where to look to tell if an edge is oriented or misoriented. The spots we look at to identify the orientation of an edge are called key stickers. In LEOR, there are 9 key stickers in total, 4 on the top, 1 on the front, 1 on the back, and 3 on the bottom. When it comes to edge orientation, there are also 2 types of edges. The first edge type is an edge that belongs in the UD layers. This white-green edge is a UD edge because it belongs in the D layer. This yellow-red edge is a UD edge because it belongs in the U layer. The second edge type are edges that belong in the middle layer. We'll call them edges that belong in the FB layers. These are called FB edges. This red-green edge is an FB edge because it belongs in the middle layer. This orange-green edge is also an FB edge because it belongs also in the middle layer. A UD edge is oriented if a UD color shows on the key sticker. This white-green edge is oriented because a UD color, white or yellow, shows on the key sticker, which is any of these 4 on the top. A UD edge is misoriented if a color that doesn't come from UD is on the key sticker. This yellow-orange edge is a bad edge because a color that doesn't come from U or D, orange, is on the key sticker. An FB edge is oriented if an FB color shows on the key sticker. This green-red edge is oriented because a front or back color, FB color, shows on the key sticker. An FB edge is misoriented if an LR color shows on the key sticker. This red-green edge is misoriented because a left-right color, green or blue, is showing on the key sticker. So I've messed up the cube a bit so that it's not the same as before, and now we are going to do an example detection. Starting off with this edge is good because it's a UD edge and a UD color shows on the key sticker. This edge is also good because it's a UD edge and a UD color shows on the key sticker. This edge is bad because it's a UD edge and a color that isn't from U or D is on the key sticker, which is blue. This edge is a good edge because it's an FB edge and the FB color shows on the key sticker. This edge is good because it is a UD edge and a UD color shows on the key sticker. This edge is good because it's an FB edge and an FB color shows on the key sticker. These 2 edges are good because they are UD edges and a UD color shows on the key sticker, which is white. This edge is bad because it's a UD edge and a color that isn't from U or D is on the key sticker, which is orange. How to orient bad edges and preserve good ones. First, I will be showing you all the triggers that preserve good edges, and I will be showing you which edges they move around. First, starting with M', U2, M. M', U2, M. So this trigger moves UF to DF. Next, M, U2, M'. M, U2, M'. So M, U2, M' does the same thing as M', U2, M, but from the back. So it moves UB into DB. Next, RY, U2, RY'. RY, U2, RY'. So basically, this moves UF to DF as well, but with R moves, and it also moves these 2 edges, but really when we're using these triggers, we're just concerned with the edges in the M slice, and for one-handed, this is a very good trigger to learn. Next, RY', U2, RY', RY', U2, RY', same thing as the one before, but from the back. And lastly, RY2, U', RY2. So U' doesn't matter which one you do. So this trigger is not actually really useful in edge orientation, but it is actually really good when you're building your stripe. So we'll get into that later. Two bad edges. From the front right position, put the first bad edge into FR and the second bad edge into UR, and then orient both of these edges with F prime, U, F. So from the front left position, you want to set the two bad edges up so that they are adjacent with each other. So then you want to put them so that one's in UF and one's in UL. Then you want to do F prime to put the first bad edge into FL, and then do U prime, L prime, U, L, F, and that will orient them. So from the back right position, put the first bad edge into BR right here, and then the second bad edge into UR, and then do B, U prime, B prime. That will orient them. And then from the back left position, set the two bad edges up so that they are adjacent with each other, like this. Then you want to put them in their spot right here. Then do B to put the first bad edge into BL. Then do U, L, U prime, L prime, B prime. And that will orient them. Four bad edges. So in front, you want to put the four bad edges in UL, UF, FR, DF. And then do R wide, U, R wide prime. Or R wide, U prime, R wide prime. It doesn't matter if you do U or U prime. In the back, you have the same thing but mirrored. So you have them in UL, UB, BR, and DB. Then do R wide prime, U prime, R wide, or R wide prime, U, R wide. Same thing, doesn't matter which one you do, U or U prime. So for 6 bad edges, you just reduce them to 2 bad edges by orienting 4 bad edges. So I'll do 4 bad edges first. So here are all my edges. Do that. And then my 2 bad edges are back here. So then I can do B, U prime, B prime. And there you go. Everything is oriented. 8 bad edges. So you take 8 of them and you reduce them to 4. And then from there you reduce to 0. So here are all my bad edges in front. So I do that to orient them. And then I can just do the rest of them from the back. So we already have one in DB. So I just need to put this one here like that. And then do R wide prime, U, R wide. And then everything is oriented. Now for EO stripe, a really nice setup is to put one edge in UL, one edge in DR, then do R wide 2, and then you can just solve them either way they need to go, and to do R wide 2 to bring them back, and that's really easy and really nice to do. If an edge is already in DF or DB, like mine's already in DB, don't take it out for the setup, just insert the other edge. And if you insert the edge, but they are opposite, just solve them and put them back in. And for two-handed, you can do the 2 columns like this, M prime, U2, M2, U2, M prime. But in one-handed, it would be better to do the setup. So now you have a 2-gen right block because all of the edges are oriented. So that makes things really nice. Alright, and then you have last layer. I hope you guys enjoyed that method tutorial. I really do like the LEOR method, and I think it's a very underrated method, and definitely a method a lot more people should hear about and get into because it's a super nice method for one-handed, and it's just really enjoyable and super satisfying. So I hope you guys enjoyed this video, and I'll see you guys in the next method.